All right, welcome to a preview of calculus, all right, featuring the absence of a green screen because my cat, October, this little troublemaker, decided that she wanted to climb to the very top of it last night, and she successfully did so until it all fell tumbling down. So we're leaving it up as a monument as we introduce calculus. Specifically, we're going to introduce differential calculus in this video. We're not going to do anything crazy. It's just kind of conceptual stuff that we're introducing to say, hey, this is where we're going. All right. We're going to start with something called the tangent problem. So remember something about slope. So if I give you some lines over here, I'm going to give you 3 lines, and I want you to look at these 3 lines and think about the slope of each of these lines. Okay. So let's say we have one line that looks kind of like this. Let's have another line on the next one that looks kind of like this. And let's have a third line on this last graph that looks like this. So we got the lines. Let's draw the arrows. Really kind of show this. We got 3. Oh dear, Jason. This is why we need a green screen. All right. The third line is right there. All right. Don't let me forget. Here, I'll put myself over here. So 3 lines. What's the slope of these lines? Okay. So slope, remember, slope is rise over run. Okay. I'll figure out where I can draw this. All right. Slope is just rise over run. So at each of these, right, we can just look at a point and say, okay, we're going up 1, right 1, up 1, right 1. The slope is 1. Here, we're going down 1, right 2, down 1, right 2. Down is a negative, so this one would be -0.5. And similarly in the last one, well, we're going down nothing, right 1. Down nothing, right 1. The slope in this last one is 0 over 1, which just simplifies to 0. So slope is going to be the single most important thing in this entire class. Slope, you're going to get sick of hearing it. Slope, slope, slope. So for lines, slope is easy. Maybe not easy, but it's definitely more manageable, or maybe it's easy depending on how good you are with lines. But where we're going in calculus, we're leaving the land of lines. Actually, that's not true. We still do a lot with lines. But let's look at another graph. Okay. This other graph, let's make it down here a little bit. I may regret this. Let's look at another function, a function that you probably are very familiar with. This function's going to look something like this. This is a parabola. Okay. I don't know the exact equation of this parabola because I didn't actually measure it out, but it's something like x squared. Maybe it's vertically stretched or compressed or something like that, but it's basically x squared. But the slope is no longer constant, right? These have different slopes at different points, right? It's much steeper here than it is here. On the right, it's going up. On the left, it's going down. Right? On the left, our slopes are going down. We always read it left to right. Right? Here, this had a negative slope. Here, this had a positive slope going left to right. All right? So when we get into functions where slope changes, that's where calculus is involved. Okay? The slope of a function, I'm going to spoil it for you. It's the derivative. Okay? Derivative just means slope. We shouldn't be talking about derivatives yet, but I've already spoiled the single biggest calculus secret. It's not a secret, but that's what we're going to be doing in calculus, okay? Talking about the slope, and we're going to be doing that through something called a derivative, okay? And we can kind of approximate the slope. All right, we can approximate the slope at different places by just looking at 2 different points on the graph and drawing a line through them. So let's call this point A. So we can approximate the slope with something called a secant line. And I guess if we really want to be accurate, this is the point a comma f of a, where this red function is the graph of y equals f of x. And for those of you who have recently done trig or precalc 2, whatever you want to call it, secant is meaning something different here, all right? We're not talking about the secant function right now, secant lines. That's how we approach and approximate slopes. And then as this point over here gets closer and closer to A, we get a better and better approximation until we get something called a tangent line. All right, and again, tangent has nothing to do with, well, depends on how, nothing is a strong word, but it's not the same tangent function as that it's not this little thing. Oh wait, it's not like that thing. So that's kind of what we're doing. That's where calculus is kind of going towards. That's what we're going to talk about in this class. How do we find this blue line? How do we use this line to find the exact slope? The exact slope, like this green line kind of bouncing off directly. That's going to be something called a tangent line. All right. And how do we calculate this? Where's the definition come from? We talk about this concept called limits. Talk about all these properties of finding derivatives, finding these slopes, and that's kind of where we're going. All right. So this is just kind of an introduction video. It introduces some very important things. Slope and derivative. October tearing down my green screen. What else could you need from a math video? Have a good day, and let me know if you have any questions.